This video will talk about simple harmonic motion, waves, and how they relate to each other. So what is simple harmonic motion? Simple harmonic motion is any periodic motion resultant of restoring force proportional to displacement, which means it is a back and forth motion, and where in a frictionless world, this motion would never stop. A perfect example to understand what simple harmonic motion is would be a spring with a mass attached to the end. Here, there is an equilibrium position, which means the spring is unstretched, and a maximum displacement, which is the distance from equilibrium position to where the spring is stretched or compressed before returning back to the equilibrium position. When talking about the force of the spring, when the spring is being stretched, it exerts a force on the mass toward the equilibrium position. This spring force decreases as it moves to the equilibrium position, causing the force to be zero. Then we have speed and acceleration. In equilibrium position, speed reaches a maximum and acceleration reaches zero. On the contrary, in the maximum displacement, speed reaches zero since it stops before it comes back, and acceleration reaches a maximum. We can also use a sine graph to get a better understanding of this motion. In this graph, we can see that time is in the x-axis and displacement in the y-axis. The x-axis represents the equilibrium position, and the red line shows the movement of the spring. We can see how once it reaches the maximum displacement, it has come to a stop, which is why speed is equal to zero, and how it goes back to the equilibrium position due to the force. Now we'll be talking about waves. So first of all, what is a wave? A wave is the motion of a disturbance. When talking about wave types, there are different types depending on what we're focusing on. First, we have mechanical and electromagnetic waves. Mechanical waves need a medium. This means that they need a physical environment through which the disturbance can travel. An example of this would be sound. On the other hand, electromagnetic waves can travel through a vacuum. An example for this type of wave would be visible light. Then we have pulse and periodic waves. A pulse wave is a wave that consists of one single traveling pulse, as shown in the animation. A periodic wave, on the other hand, is when the source of a wave's motion is a periodic motion, as shown in the video. Lastly, we have transverse and longitudinal waves. Transverse waves are waves where the vibration are perpendicular to the wave motion. In this case, it would be the blue line. And longitudinal waves are waves where the vibration and the wave motion are parallel to each other. Now let's talk about the elements of a wave. First, we have the highest and the lowest point of a wave. The highest point is called the crest, and the lowest point is called the trough. The next element is the measurement of the maximum displacement from equilibrium, and this is called amplitude. Then we have what a wavelength is. This is the distance a wave travels during one cycle. This can either be measured from crest to crest or from trough to trough. Lastly, we have period and frequency. Period is the time for one cycle to happen, or one wavelength, which is 1 over frequency, and frequency is the number of cycles to happen in one times unit, which is 1 over period, and it's measured in hertz. And that's the end for simple harmonic motion and waves.